Hello everyone. In this presentation, I will be talking about our work probing critical learning dynamics of PLMs for hate speech detection. Given the volume of hate speech that is available online, we are now developing computational techniques to help content moderators. These computational techniques are often based on fine-tuning a language model for the specific data set for a given language or for a given context. Given that these systems are designed for a very specific combination of data sets and LLM, we want to probe whether there are any commonalities across the data sets and PLMs that are used in hate speech detection and whether that can be useful for the hate speech community at large or not. In this regard, we go over 5 research questions that are broadly classified into the impact of pre-training and fine-tuning strategies that eventually lead to the improvement in performance of HP detection systems. And here the performance is measured in terms of macro F1 score. In this regard, we go over 7 English hate speech data sets that are binarized. So we are looking into hate versus non-hate classification, and we run our experiments over 5 variants of PLMs, which means the pre-trained language models. In addition, we look into classification heads that are of varying complexity, and all of these experiments, each of the setup that we have discussed is run for each dataset and PLM combination on 3 classification head in order to capture the variation that might arise from random seeding. This is an overview of the data sets and the PLMs that are employed in our study. The detail of the experimental setup is available in the paper. Coming to the question of what is the impact of analyzing pre-training strategy, we go back to the fact that most of the PLMs that we employ for NLP tasks, especially HP detection, are picked from publicly available PLMs like the Hugging Face platform. And these PLMs that are made public usually are the ones that are either the from the last checkpoint or the best checkpoint with respect to the pre-trained strategy that was used to train them. The assumption is that the model that is giving the best result on the pre-trained performance will also give us best results in downstream tasks. We want to challenge this hypothesis by asking what is the role of intermediate checkpoints, and can intermediate checkpoints give equally good performance as compared to the checkpoints that are termed as the last checkpoint or the best checkpoint. In this regard, we pick 84 checkpoints that are released for the Roberta English model. These checkpoints are released one per epoch for 84 epochs for the training of the Roberta English model on our MLM pre-training task. And for each of these checkpoints, we fine-tune it for the task of HP detection, where we keep the PLM frozen. We fine-tune the classification head for the given dataset and see what is the variation in performance across the epoch-based checkpoints. Interestingly, we observe that when we take early epoch checkpoints, like checkpoint 2, 3, and 4 especially, they lead to the highest macro F1 score. Even though, like in the figure 2, we see that there is variation across checkpoints, meaning that at different epoch, the model is learning different syntax and semantics about hate speech. We largely see that the earlier checkpoints are leading to the highest gain in performance, which raises the question that not all downstream tasks may need a full-fledged pre-training system, especially as observed in case of English hate speech, that it can lead to a good performance even on earlier checkpoints. Continuing from our assessment of pre-training checkpoints, we look at whether continually updating the PLMs with more data or more training, does it help in hate speech detection. This stems from the fact that a lot of hate detection requires world knowledge. And if the PLMs are getting updated on their world knowledge, does it translate into improvement in hate speech? Here we look at 3 Roberta English models that were periodically introduced on Hugging Face, and we see whether these periodic updates lead to an improvement in performance. Unfortunately, it does not. While we see that for some data sets like Fonta, there is a huge jump in macro effort, for most of the data sets, irrespective of when the model was released, the performance remains static. Our assumption here, or the takeaway here, is that since most of these data sets were released much before even Roberta base came along, we are assuming that the information that needs to be captured with respect to the world knowledge associated with these data sets is already captured even by the base model. Another thing to look into is the fact that most of these data sets capture more explicit form of hate. So the knowledge required in terms of lexical or slur knowledge is already captured well enough with the base model. So the newer models don't add to that explicit knowledge specifically. In this regard, we are again see that you don't necessarily have to go for a newer PLM in order to say that it'll lead to a better performance in hate speech. Moving away from pre-training strategies to fine-tuning strategies, we are interested in looking into how individual layers contribute to detection of hate speech. Here again, the assumption is that different layers will capture the hateful connotation to different extent. The setup here involves that we keep all the layers frozen except for the layer that is under analysis, and probing that layer along with the classification head, we see what is its performance measured. Here again, we see that similar to the existing literature that says that the layer that are closer to the classification head will lead to more performance gains. We also observe the same for 5 out of our 7 data sets. Interestingly, we see that this trend of the layer closer to the classification head leading to improvement in performance is not true for MBOT, where the middle set of layers are giving better performance. We assume that this may be stemming from the fact that overall, in terms of MBOT, it is trying to balance between generalization versus specificity with respect to a particular language or a particular syntax, because of which the middle layer seems to be performing best. We also see that for MBOT, that its performance is not at as good as it is for other English PLMs like Word, WordTweet, or HateWord. This again stems from the fact that due to increase in the number of languages that MBOT is trying to capture, there is a loss of performance for English-only data sets. Finally, we look into the influence of the classification head. Does a BERT model with a more complex classification head lead to an improvement in performance? This again is not necessarily true. We see that even though there is a jump in performance going from a simple to a medium complexity of the classification head, going from medium to complex does not guarantee an improvement in performance. This means that there's a trade-off between the complexity of the classification head and the performance, and the optima is reached in terms of the medium classification head, which is a two-layer of feed-forward network with intermediary value activation in between them, the medium setup that we employed here. We also observe in this RQ, not necessarily reflected in this image, but across the data set, we observe that when we combine a general purpose PLM like BERT along with a complex classification head, the performance of that setup is as good as that of domain-specific models like HateBird combined with a simple classification head, which calls into question the need for domain-specific classification head, and also trying to bring up the question of does continued pre-training lead to similar performance gain as using a complex classification head. In conclusion, we have 3 pertinent questions for the larger NLP community. The first one being the requirement for releasing intermediate checkpoints so that we can perform this analysis for other languages as well as for other NLP tasks. The second is whether we need to look into MBOT-based models if you already have a monolingual model available, and especially if your data set is monolingual in nature. The third, of course, is calling into question the domain-specific models, whether MLM as a strategy is good enough to say that it has captured the domain knowledge that we require from a domain-specific models. In terms of the hate speech literature, we have a few recommendations. One, the most basic ones of them being that we should report our results on multiple seeds. We should report our results on multiple classification heads, especially if you are comparing bird with hate bird. But we also have some non-trivial recommendations, like if you are using a model like HateBird and if your data set is English, then we highly recommend that you also go for a bird tweet and report your results on that. We also want this to be a broader discussion that there needs to be dynamically updated or continuously updated hate speech corpus so that we can keep measuring the delta improvement when newer PLMs come into play. Overall, we observe that hate speech detection is, as known, is a subjective and nuanced topic. And while there are some trends that are applicable, we still need to look into this from the perspective of multilinguality and implicit hate speech, which we hope to do in future. Thank you.